You've seen it 1,000 times. The moon rising on the horizon, impossibly huge. So large it feels like you could reach out and touch it. But wait a few hours, and when that same moon is high overhead, it looks tiny. What's going on? Is the moon actually changing size? The answer is no. But the truth is even stranger. This is the moon illusion, a mystery that has baffled scientists for thousands of years. Here's the paradox. When the moon is on the horizon, it's actually farther away from you than when it's directly overhead. As astronomer Susanna Kohler from the American Astronomical Society explains, you have to look across the entire diameter of Earth, making the moon one Earth radius about 4,000 miles farther away. So logically, the horizon moon should appear smaller, not larger. Yet photographs prove the moon's size remains exactly the same whether it's rising, setting, or overhead. So if the moon isn't changing, what is? This mystery has puzzled observers since ancient times. Aristotle thought the atmospheric moisture magnified the moon like a lens, but modern photography proved him wrong. Atmospheric refraction actually makes the moon look slightly squished, not enlarged. The real answer lies somewhere far more surprising, inside your brain. Scientists have proposed many explanations over the years. One popular theory suggested that when the moon is near the horizon, surrounding objects like trees, buildings, and mountains provide a size comparison, making the moon appear larger by contrast. But here's the problem. The illusion persists even over featureless landscapes. Sailors on the open ocean, where there are no buildings or trees for reference, still report seeing an enormous moon on the horizon. So it can't just be about comparison with nearby objects. As neuroscientist Bart Borghuis from the University of Louisville explains, the moon illusion is something that happens inside the brain when we construct our perceptions of size. To understand it, we need to understand how your brain actually perceives size in the first place. Size perception is a two-step process. First, your retina records the physical size of an object's image, essentially how much space it takes up on the back of your eye. But that's only half the equation. Your brain then adjusts this measurement based on how far away it thinks the object is. This principle is called Emmert's law. Here's how it works. If two objects create the same size image on your retina, but one appears farther away, your brain automatically assumes the distant one must actually be larger. This is usually helpful. It's how we navigate the three-dimensional world. But with the moon, this system breaks down. The key insight came from a landmark 1962 study published in the journal Science. Researchers discovered that most people don't perceive the sky as a true hemisphere. Instead, we see it as a flattened bowl, closer overhead and stretching far away toward the horizon. This misperception is what triggers the illusion. In the crucial experiment, researchers showed participants a simulated moon at the horizon with visible terrain. People consistently perceived it as larger because the landscape made it seem farther away. But when the same moon was shown without any terrain, no distance cues, the illusion completely disappeared. This is similar to the famous Ponzo illusion, where identical lines appear different lengths based on perspective cues. The principle? A filled-in space is perceived as more extended than an empty space. So when your brain thinks the horizon moon is farther away, it compensates by making it appear larger to match the retinal image size. You can experience this brain trick yourself. Stare at a bright light for several seconds, then look at a blank wall. You'll see a dark afterimage. Now, switch between looking at a nearby wall and a distant one. The afterimage will appear to change size even though the image on your retina stays constant. Pretty wild, right? The moon illusion reminds us that perception isn't reality. It's our brain's best guess. Even knowing the science that you'll still see that giant horizon moon. But now you know, it's not the moon that's extraordinary, it's your brain. And honestly, that makes it even more amazing.